Okay, electronegativity of d block elements. Electronegativity is the tendency of an atom to attract the shared pair of electrons towards itself in a chemical bond. The electronegativity of d block elements shows characteristic strengths due to presence of partially filled d orbitals. General trends across a period, left to right, electronegativity generally increases from left to right across a transition series. The increase is less regular than in the S and P block elements because the added electrons enter the inner n-1 d orbitals, which partially seal the nuclear charge. For example, D series, chromium, manganese, ferrous, cobalt, nickel, copper. The values vary on only slightly across the series. Down a group, electronegativity changes very little down a group of transition elements. This is because the increase in atomic size is compensated by poor shielding effect of d and f electrons. Reasons for moderate electronegativity. The block elements have intermediate electronegativity, generally between 1.2 and 2.2 on the Pauling scale. Their partially filled d orbitals and relatively high effective nuclear charge give them a greater attraction for bonding electrons than S block elements, but a lower attraction than highly electronegative P block elements. Consequence of electronegativity, they readily form covalent compounds with nonmetals. They can exist in multiple oxidation states because the energies of N-S and N-1d electrons are similar. Their oxides change from basic to amphoteric and then acidic with increasing oxidation state. They readily form coordination compounds by accepting lone pair from legions. In comparative electronegativity, S block have the low electronegativity, higher electropositive character, but in case of D block, moderate electronegativity, intermediate forms both ionic and covalent compounds. In case of P block, it is the high electronegativity, strongly electronegative. The electronegativity of D block elements is moderate and changes only gradually across a period and very little down a group. This moderate electronegativity contributes to many of their characteristic properties, including variable oxidation states, complex formation, catalytic activity, and ability to form both ionic and covalent compounds.